solving just because of the constants involved here. But let me tell you, this is very simple question and you can solve it very easily. Just watch the video completely. Here, the very first thing, whenever this question of integration comes to you, you always think what method I need to apply. And when I see the product of these two functions here, immediately one thing comes to my mind is partial fraction. But remember, partial fraction is applied only when you do not have square root in case of factors. So here I have square root, therefore I cannot apply partial fraction. So the next option I am having in this question is completing the square. And to complete the square, I need to multiply these. If I multiply, so it will be x square minus ax minus bx plus ab. Simply after multiplication, I'm getting this. Now, if I look at this carefully, I can see in middle two terms, I have minus x common. So I can write it as minus a plus b into x plus ab. Now, to complete the square, there are few rules. Complete the square means I need to complete the formula a plus b whole square. We know this formula very well. This is a square plus 2ab plus b square. Now we have this x square in place of a square, not an issue. We need to arrange 2ab. That means the term with x should have 2, but currently it is not having 2. What I will do, I will multiply with 2 and divide with 2. So in this way, if I compare these two, I can find that a square is equivalent to x square, and then I have minus here, so I will be using the formula of minus here, not the difference. So minus 2 into a plus b upon 2 into x. Now, if I compare, what I will find? I will find 2 is same, not problem. B is not known because a square I'm comparing with x square. So the value of a is x. So accordingly, the value of b must be a plus b upon 2. So what is the main takeout from this step is leaving 2 and x, whatever is left with me is the b, and I require b square. To arrange b square, what I will do, I will take the square of a plus b upon 2 and add because it is required. But we know in equations, we cannot add such things like this. So I will subtract also to make a balance. Right? Very important step. I hope you understood. If not, then just backward the video and you will understand. If you do not understand, watch the video from backward, you will get to know. Now, if I see the terms x square, this term, and this term, this can be written as a minus b whole square. And a minus b whole square means what? It means x minus a plus b upon 2 whole square. Now we have to see what is left. I am left with this term and this term. If I take the LCM here, because square is complete, if I take the LCM, this will be 4ab minus a square minus b square minus 2ab, because this minus will get multiplied with all the terms inside. So this is the term I will get. Then after this, I will have dx upon square root x minus a plus b upon 2 whole square. Then if I take minus outside, I will have a square plus b square minus 2ab upon 4, like this. Now, this can be written as dx upon square root x minus a plus b upon 2 whole square minus a minus b upon 2 whole square. So, we can compare this with the formula x square minus a square inside the root. And we know this formula. What formula? Integral dx upon under root x square minus a square. And this formula is log of x plus under root x square minus a square plus c is obvious. This is the formula which I will be using. So I'm using this formula log. Then in place of x, I'm having ax minus a plus b upon 2. In place of x plus under root the same term. But this term, in place of this, I can take whatever was there in the question. So it will be x minus a into x minus b, because I just completed the square, didn't make any changes to the question. So this is my answer for this.